Right, so today I'm taking an introduction to differential calculus. This is just a beginning to show us what calculus is about. We'll be defining some terms as regards to the differential aspect of calculus. Now there is differential and there is integral aspect that we'll be taking on another course. But for today, let's focus on differential aspect of calculus. Now the first term we're going to be defining is first off, what is a function? We're going to talk about what a function is. Alright, we're going to define range as the range of a function. We're going to define the domain. What do we mean by domain? We're going to define codomain. Right, so what is the codomain of a function? What's a function itself, the range of that function, the domain, and of course the codomain. Then before we go to, so these are just terms. These are terms we include. Then we'll go to the types of function. Go to the types of function. Types of functions are where you have, right, type of function. We have odd functions. Alright, we have even functions. Yes, we have an even function. So what does it mean when we say a function is odd? What does it mean when a function is even? We have increasing, right, slash decreasing functions. Alright, we'll find those, talk about that. Then increasing and decreasing functions. Then we'll also talk about strictly increasing and decreasing functions. Strictly increasing and decreasing function. Then we'll talk about how to find the range of a function. Okay, finding the range of a function. But other types of functions, we have odd functions, even functions, increasing and decreasing functions, then also strictly increasing or decreasing functions. Alright, we also have injective. Let me just put it in one line. We have injective, we have surjective, and we have objective functions. Alright, so we're going to take note about that in today's course. First, we'll take the terms, types of functions, then how to find some variables in the functions like your range, your domain, your codomain, and the likes of them. So the thing we're taking is, what is a function? Now, a function itself is an expression that shows us the relation between set x and y. Alright, just imagine two sets, x and y. Set x has its values and y has its own values. Now, a function is an expression that shows us the relationship between two sets and x and y, between two sets x and y. So we'll explain more on that. The second term we want to define is range. A range of a function is a subset of the codomain values. Alright, then domain. The values of the set x that we're allowed to use are referred to as the domain. Then lastly, we have the codomain, the values of the set y that can be potentially produced. Now, with all of this we've said, let's take an example. Let's say you have a function like fx, right, is equals to x squared. Now, this is referred to as a function. The whole of this as well is a function, right? Fx is what we refer to as the codomain. Why is it the codomain? Because fx is equivalent to y. So we can write this as y is equals to x squared. Right? This represents the same thing. So this is the whole function. This is what the function represents. Fx simply implies that we impute a value of x into this function. Alright, let's say that x, that's the domain values we want to use, is a member. Alright, this represents that it is a member of all sets R. What does R represent? Real numbers. So we can use any numbers that are not complex numbers. So let's say impute 2 and you evaluate 2 square. So you now say that fx is equals to 2 square, which is equals to 4. Now we have that 2 is our domain value, right? 4, which we produce, is our codomain value. That's the value of y. Now, for a particular set of real numbers, the values of y that can be produced generally, or we say potentially, is generally referred to as the codomain. So a codomain doesn't refer to as one value, but rather the possible values of y we can have. Then a range is a subset of our codomain, which represents the actual values of y that will be produced when a value of x is applied to the function. Okay, alright. So having defined these functions, let's now take some types of functions. So an odd function, we do not need a definition, but an odd function is represented mathematically as whenever you have a function f of minus x, this is minus x, and that is equivalent to minus f of x, we refer to this as an odd function. So this is the practical mathematical representation, right? So this is an odd function. Let's take an example. Let's say you have a function of cos x, right? Cos x. Now, want to determine whether this is an odd or an even function. So remember, we said that f of minus x will give you minus fx. So taking a value of x, though, let's take a practical value of x. Let's say x is 2, right? So replacing 2 as value of x, we'll have that the function f of x will be equals to cos of, right, minus 2. We do not need to change x here. This represents the function itself, cos of minus 2. Now, generally from trigonometry, you know that whenever you have cos of minus theta, this is equivalent to minus cos theta, right? So this is going to give us f of x for cos of minus 2 will be equals to minus cos 2 degrees, of course. So see that this represents actually what we will here, which is now minus fx, right? So this is because you can divide both sides by minus 1 actually to get minus fx behind here, right? So this is an example of an odd function. The next we have even functions. Now even functions are of course the opposite of odd functions. So even functions are represented as whenever you have f of minus x again. So instead of using minus fx, this time we yield fx. The minus is gone, right? So let's take an example of an odd function. An example is that if you have a function fx is equals to sine x, right? So f of x, now let's take x as 2. So we have f of x will be equals to sine of minus 2, right? If we take the sine value of minus 2, you are going to get sine 2. Why? Because generally sine minus theta is equivalent to sine theta. So this means that f of x is equals to sine of 2 degrees. So this becomes our answer. So these are odd and even functions explained. The next we have are increasing and decreasing functions. But let's take increasing functions. Though a decreasing function, of course, is the direct opposite of decreasing functions. Alright, so let's say you have 2 points on the x-axis. Let's say you have 2 points on the x-axis, x1 and x2. Alright, where x1 is less than x2. Now what does this indicate? This indicates you are moving to the right of the x-axis, right? You are moving towards the right, so x1 will be less than x2. x2 is a bigger value. Now if f of x1 is less than f of x2, we say that this function is increasing, right? We say that the function is increasing. x1 is less than x2, you have a bigger value of x2 because you are moving to the right of the horizontal axis, and then you have f of x1, which is actually the vertical axis, the y-axis, is also less than f of x2, which implies that this is growing. So as x is increasing, your y is increasing. That's represented. So we will have something like this. for your x value, your x axis, for your y axis. So you are going to have a straight slope. So this is what we're going to be using. Here we'll have f of x2, here we'll have x2. All right, so here we'll have x2. Well, this is the x-axis, this is the x-axis. Here we'll have f of x2, so something similar to that. Now this function, this statement is not complete, because similar to an increasing function, we have a strictly increasing function. Now a strictly increasing function only has this slope. All right, when I say it only has the slope, meaning that the y value never stops increasing for a strictly increasing function. But meanwhile, for a increasing function, I would say that the y value, all right, can flatten out. The y value can flatten out. So that's going to change our mathematical expression. For the y value to flatten out, meaning that f of x1 and f of x2 can remain the same for a certain values of x1 and x2. So we can say that f of x1 will be less than or equal to f of x2. So this is what defines an increasing function. Then it is the direct opposite for a decreasing function. So for that, we're going to have, where you have 2 points as the same x1, you're always moving to the right. That's the increasing values of x2. x1 is less than x2, where x1 is less than x2, where this time f of x2 now becomes less than or equal to, right, f of x1. So this is a decreasing function, strictly increasing function. Now remember we said something about for an increasing function that the y value can flatten out, meaning that for two values of x, the y value cannot change. F of x1, f of x2, they can remain the same. But meanwhile, for a strictly increasing function, it is never like that, right? The graph, the slope, it always keeps rising. So we can say that x1, just write it where x1 less than x2. All right, so it is strictly increasing. X1 is less than x2 if it becomes strictly increasing if f of x1 is less than or f of x2. So we can say that a strictly increasing function is represented by strict inequalities, right? But just an increasing function or a decreasing function, they are weak inequalities, right? So they can, the y value can flatten out. Now we have this for a strictly increasing function. Then for a strictly decreasing function, we'll have x1 less than x2. This always remains constant. We come to decreasing if, right? So we just alternate where the y values are placed. F of x2 is now less than f of x1. So that's a strictly decreasing function. And lastly, we're taking injective, surjective, and objective functions. We're taking the last type of functions, which are injective functions. Injective, also referred to as one-to-one functions. Now, injective functions, these are functions, right? So we find them, these are functions where each x value, that's each value of the set x, each x value has distinct images in the set y. Now what it simply means, it means that each value of the domain has one and only assigned value of the codomain, right? So it has distinct images in the set y. So we can also say that this is where each domain value, right, because you know that the x value represented by the domain has the possible values of x you can impute into the function. So each domain value is assigned to only one codomain value. So it's sort of like a unique aspect that one codomain value has only one domain value, right? There is no sharing among them. So assign only one co-domain value. Now let's take an example. Now first, before we take the example, is that we need to write out the mathematical expressions for injective functions. Now injective functions mathematically is only possible. We say if f of a, right, is equals to f of b. Now we must understand that f of a and f of b are two different functions. Alright, so this represents the co-domain value of functions. Now for them to be equal, for the y value of the function to be equal, it means that a should be equal to b. So for two functions to be equal, meaning their domain value must be equal. Alright, so there is a uniquely assigned co-domain value to each domain value. So this is referred to as an injective functions. Now the next we're taking are surjective. We'll take this on number 5. Surjective functions. These are referred to as onto functions. Alright, they're referred to as surjective functions. Now a surjective function, these are functions, these ones are quite easy anyway. They are functions where the codomain is equivalent to the range, where the codomain is equivalent to the range. Now what this simply means, remember our definition of codomain are the possible values of y we can get from a function. You must understand that y represents f of a, in this case f of a or f of x. That's a function that has already been done, that represents the y value. So we say that codomain represents the possible values of y we can get. Something is possible does not necessarily mean it will come to reality, but if it does, we refer to those as a range. So the possible values of y which eventually come to reality now becomes the range of that function. Now surjective, also referred to as onto functions. Now the last are objective functions. Objective functions. So objective functions are simply functions. We say that they are functions which are both they are both surjective and injective. So when they have these two properties simultaneously in one function, when you have these two properties simultaneously in one function, that function is said to be objective. So they are both injective and surjective functions. Injective and surjective functions. So we've talked about type of functions and terms in functions. Now let's take some exercises exploring the examples. Exercises involving introduction to differential calculus.